Despite being nearly 600 million miles away from Earth, one of Jupiter's moons has become a source of great fascination for scientists here on our planet. This particular moon has been transmitting peculiar and enigmatic messages to NASA's Juno probe. The question arises, could these messages be attempts by extraterrestrial beings to communicate with us? Furthermore, what exactly do these messages convey? In this video, we delve into NASA's recent revelation that one of Jupiter's moons has initiated communication with the Juno probe, along with other mysteries of the vast expanse of deep space. Jupiter, as a planet, stands out for numerous reasons within our solar system. Its sheer magnitude is one remarkable feature. It is twice as massive as all the other planets combined and has a radius of 43,440.7 miles, 69,911 kilometers. To put this into perspective, Jupiter is 11 times larger than Earth. To visualize the scale, if Earth were the size of a nickel, Jupiter would be comparable to a basketball. Additionally, Jupiter's average distance from the Sun is approximately 484 million miles, 778 million kilometers, or around 5.2 astronomical units, O. An O is the distance between the Sun and Earth, and sunlight takes approximately 43 minutes to travel from the Sun to Jupiter. What other unique attributes does this colossal planet possess? Jupiter boasts the shortest day in our solar system, completing a full rotation in just 10 hours. However, due to its vast distance from the Sun, a year on Jupiter is equivalent to 12 years on Earth. This celestial giant is an ancient entity, having formed alongside the solar system approximately 4.5 billion years ago. Intense gravitational forces brought together swirling gas and dust, resulting in the formation of Jupiter. Interestingly, this gas giant consumed most of the remaining materials after the Sun's formation. Consequently, Jupiter possesses the necessary ingredients to become a star, but it did not reach the critical mass required for the fusion reactions that produce heat and light, characteristic of stars. Such a cosmic origin contributes to Jupiter's unique nature. Jupiter shares a significant portion of its composition with the Sun, primarily consisting of hydrogen and helium. However, as one delves deeper into its hemisphere, both pressure and temperature increase, causing the hydrogen gas to compress into a liquid state. This phenomenon gives rise to the largest ocean in the entire solar system, albeit not containing water but rather vast quantities of hydrogen. At depths approximately halfway to its center, the pressure becomes so immense that hydrogen atoms lose their electrons, resulting in the liquid becoming electrically conductive, similar to a metal. This unique characteristic plays a crucial role in Jupiter's fascinating dynamics. Jupiter's rapid rotation is believed to induce electrical currents in the aforementioned region, ultimately generating the planet's immensely powerful magnetic field. As a consequence, Jupiter possesses the most potent magnetic field among all the planets in our solar system, surpassing the Earth's strength by a staggering factor of approximately 20,000. These intricate processes shed light on how Jupiter's fast rotation actively drives the formation of its magnetic field. Adding to its allure, Jupiter proudly displays a ring system, a revelation that came as a complete surprise when NASA's Voyager 1 spacecraft discovered them in 1979. Although the rings consist of small, dark particles that pose a challenge to observe, they undoubtedly contribute to the planet's captivating visual spectacle. Of course, any discussion about Jupiter would be incomplete without mentioning its impressive collection of moons. Often regarded as a miniature solar system due to the abundance of these celestial companions, the exact count of Jupiter's moons remains a moving target as scientists continually make new discoveries. Presently, no fewer than 79 moons have been identified orbiting this gas giant. Jupiter's massive size, exceeding that of Earth by more than 300 times, affords it the stability necessary to exert a substantial gravitational force over a vast area, effectively maintaining the presence of multiple moons in their respective orbits. This intricate dance of moons around Jupiter is a captivating sight that continues to captivate and perplex NASA scientists, making them ponder the mysteries of this enigmatic planet. The group of the 4 largest moons orbiting Jupiter is famously known as the Galilean moons, attributed to their discovery by Galileo Galilei. These moons, namely Europa, Ganymede, Callisto, and Io, hold significant scientific intrigue and are distinctive in their own right. Arranged in order of proximity to Jupiter, Callisto is the furthest moon from the gas giant. Despite being the smallest among the quartet, it possesses the distinction of being the most heavily cratered object in the entire solar system. Roughly comparable in size to Mercury, Callisto experiences the least magnetic influence from Jupiter. Next in line, situated closer to Jupiter than Callisto, is Ganymede, which holds the distinction of being the largest moon within the group. Remarkably, Ganymede is the only known moon in the universe that generates its own magnetic field. Following Ganymede, Europa takes its place. Similar in size to Earth's moon, Europa captivates scientists due to its cracked and streaked icy surface, which exhibits a notable degree of reflectivity. This attribute makes Europa one of the brightest moons observed in the cosmos. Intensive research efforts are focused on Europa as there is a suspicion that beneath its icy crust lies an ocean that might potentially harbor life. Lastly, occupying the closest orbit to Jupiter is Io, a moon that leaves scientists on the edge of their seats. Io, being the most volcanically active celestial body in our solar system, showcases a tumultuous and violent nature. Its surface is adorned with numerous volcanoes erupting sulfurous plumes, shooting hundreds of miles high. Sandwiched between Europa and Ganymede, Io grapples with the gravitational tug-of-war between these two moons and Jupiter itself. These tidal forces are responsible for generating the immense heat that fuels Io's intense volcanic activity. Consequently, Io's landscape is in a constant state of transformation, as fissures continuously release lava onto its surface, filling impact craters and forming new expanses of liquid rock. While scientists are yet to ascertain Io's precise composition, it is suspected to consist of molten sulfur and its compounds, or potentially silicate rock. Although Io's surface temperature reaches scorching heights of up to 3,000 degrees Fahrenheit due to its volcanoes, the moon's thin atmosphere primarily consists of sulfur dioxide. In stark contrast, the average surface temperature of Io plummets to a chilling -202 degrees Fahrenheit. This stark juxtaposition of extreme temperatures has earned Io the moniker, celestial body of fire and ice. With an orbital distance of approximately 262,000 miles from Jupiter, Io completes its orbit in about 1.77 Earth days. The Moon itself boasts a mean radius of 1,132 miles, slightly larger than Earth's moon. Observing images of Io, one can discern its oblong shape. This peculiarity stems from Io's elliptical orbit around Jupiter. As the Moon traverses its elliptical path, the gravitational pull exerted by Jupiter fluctuates, varying in strength depending on its proximity to the gas giant. This continuous gravitational push and pull in different directions gives rise to a bulging effect on Io's surface, causing it to expand by up to 330 feet or 100 meters. Consequently, this dynamic movement results in rocks on Io grinding against each other, generating tremendous amounts of heat, approximately 20 times more heat flow than that observed on Earth. If Io were the only moon orbiting Jupiter, its orbit would have likely settled into a stable, circular path. However, Io's fate is one of perpetual disruption due to the gravitational influence of Europa and Ganymede. Despite being relatively small, Io exerts its own gravitational pull on Jupiter, leading to electrifying consequences. Io's orbit intersects with Jupiter's powerful magnetic field lines, effectively transforming Io into an electric generator. As a result, Io can accumulate a staggering potential of 400,000 volts across its surface, generating up to 3 million amperes of electrical current. Ironically, this electrical current finds its way back along Jupiter's magnetic field lines, culminating in spectacular lightning storms in the gas giant's upper atmosphere. However, the relationship between Jupiter and Io goes even deeper. As Jupiter rotates, it experiences a significant loss of Io's material, with approximately 1 ton being stripped away every second due to magnetic forces. This liberated material becomes ionized and forms a distinctive torus-shaped cloud of radiation known as a plasma torus. Some of the ionized particles are drawn into Jupiter's upper atmosphere, giving rise to captivating auroras. Notably, The Hubble Space Telescope has captured instances of this activity, revealing the combined influences of Io and another Jovian moon, Ganymede, on Jupiter's Aurorus. Io has more surprises in store, and the most recent discovery has left scientists baffled. Thanks to NASA's Juno spacecraft, researchers have been able to listen in on radio emissions emanating from Io. The abundance of volcanoes on this moon, coupled with the effects of Jupiter's magnetic forces, causes Io to lose approximately 1 ton of gases and particles per second into space. These expelled materials become ionized, breaking into ions and electrons that rain down on Jupiter. When the accelerated electrons become trapped in Jupiter's magnetic field and are directed towards the planet's poles, they generate a phenomenon known as decimeter radio waves, a subject of great interest for scientists. When Juno is positioned correctly, it has the ability to detect decametric radio emissions, DAM, and gather valuable data. Through analyzing this data, researchers have managed to identify the specific locations within Jupiter's immense magnetic field from where these radio emissions originate. This information has provided insights into the behavior of the colossal magnetic fields generated by gas giants. The research team has determined that the radio waves emanate from a distinct region that can be described as a hollow cone, where the conditions align perfectly. This includes the right strength of the magnetic field and an optimal density of electrons. The radio signal exhibits a rotational pattern akin to a lighthouse beam, and Juno is capable of capturing it only when the spacecraft is within the illuminated path of the signal. The radio data has also yielded an intriguing revelation regarding the electrons responsible for generating these radio waves. It turns out that they emit an astonishing amount of energy, measuring 23 times higher than initially estimated by researchers. Furthermore, investigations have suggested that these electrons may have additional sources, such as the planet's own magnetic field or solar winds originating not far from Jupiter. Meanwhile, Uranus, which orbits even farther from the Sun than Jupiter, has presented its own enigmatic behavior. A peculiar heat wave has caused a surprising warming effect on Uranus's rings, despite the significant distance from the Sun. This phenomenon was unveiled through thermal imaging of Uranus's rings obtained by telescopes in Chile. The temperature recorded was a chilling -320 degrees Fahrenheit, equivalent to the boiling point of liquid nitrogen. While this temperature may seem extremely cold from an Earth perspective, in the vastness of space, where temperatures can approach absolute zero and atomic motion ceases, -320 degrees Fahrenheit is relatively warm. Given Uranus's considerable distance from the Sun, it receives only a fraction of the solar heat that Earth does. The ice giant completes its orbit around the Sun at an average distance of 19 astronomical units, (O). The cause behind this unusual warmth observed on Uranus is still a mystery to scientists. However, this unexpected temperature variance highlights the distinctive nature of Uranus's epsilon ring, which is the brightest and densest among the planet's rings. In comparison to other ring systems in our solar system, the epsilon ring sets Uranus apart. While every giant planet in our solar system, including Jupiter, Saturn, Uranus, and Neptune, possesses its own set of rings, Saturn's rings stand out as the most spectacular and well understood. Their visibility, even with a small telescope, and the comprehensive study conducted by NASA's Cassini mission have contributed to a deeper understanding of Saturn's rings. Nevertheless, the rings of Uranus exhibit significant differences. Unraveling the mystery behind the warming temperature on Uranus remains an ongoing endeavor for scientists.